Welcome everyone to this SQL training session. Today we will explore a comprehensive SQL guide designed for interview preparation and skill development. Whether you are a data analyst, developer, database administrator, or student, this session will cover essential SQL concepts commonly used in technical interviews and real-world database management. This guide was prepared by Narges Aminimoghaddam and MahdiAbolfathi from RAI Framework LLC to provide both practical insights and foundational knowledge, helping you build confidence and succeed in SQL-related challenges. This training focuses on answering some of the most important SQL interview questions through 20 key topics with concise explanations, practical examples, and clear comparisons. We will cover SQL fundamentals, databases, primary and foreign keys, normalization, and join operations, along with important comparisons such as delete versus truncate, union versus union all, and where versus having. Additional topics include transactions, indexes, ACID properties, deadlocks, and the difference between databases and schemas. This structured approach is designed to build a strong understanding of both fundamental and advanced SQL concepts. Let's start with the basics. What exactly is SQL? SQL stands for Structured Query Language. It's a powerful, domain-specific language used to manage and manipulate relational databases. Think of it as the universal language for interacting with data. SQL allows us to perform the essential CRUD operations: create, read, update, and delete data. For instance, a simple select from employees command reads all data from an employees table. Mastering SQL is fundamental for anyone working with data, providing the ability to efficiently retrieve, modify, and manage information stored in database systems. At the heart of SQL are databases and tables. A database is an organized collection of structured information, or data, typically stored electronically in a computer system. Within a database, data is organized into tables. Think of tables as spreadsheets, where information is stored in rows and columns. For example, you might have tables for employees, departments, or orders. Each table holds specific types of data, with columns representing attributes and rows representing individual records. This structured organization is vital for efficient data retrieval, allowing us to quickly access and analyze information as needed. Primary and foreign keys are essential for designing reliable databases. A primary key uniquely identifies each record in a table, cannot contain null values, and ensures data integrity. A foreign key creates relationships between tables by referencing a primary key in another table, maintaining referential integrity. Together, these keys help build well-structured and connected database systems. Database normalization is a systematic process of organizing the tables in a relational database. Its primary goal is to reduce data redundancy and improve data integrity and consistency. By applying a set of rules known as normal forms, we decompose larger tables into smaller, more manageable ones, ensuring that data is stored logically. Normal forms like 1NF, 2NF, 3NF, BCNF, 4NF, and 5NF guide this process, each addressing specific types of data anomalies. Proper normalization leads to a more efficient database design, which in turn improves scalability, maintainability, and overall data quality, making it easier to manage and query complex data sets. When working with multiple tables, SQL join operations become indispensable. Joins are used to combine rows from two or more tables based on a related column between them. There are four main types of joins, each serving a distinct purpose. An inner join returns only the rows that have matching values in both tables. A left join, sometimes called left outer join, returns all rows from the left table and the matching rows from the right table. If there's no match, null values appear for columns from the right table. Conversely, a right join returns all rows from the right table and matching rows from the left. Finally, a full join or full outer join returns all rows when there is a match in one of the tables. Let's clarify the difference between the delete and truncate commands, as they are often confused. While both remove data, they operate quite differently. Delete is a DML, data manipulation language command that removes one or more rows from a table based on a specified where clause. It performs row by row removal, which means it's generally slower and it generates undue information. Delete operations can be rolled back. In contrast, truncate is a DDL, data definition language command that removes all rows from a table, effectively reinitializing the table structure. It's much faster than delete for removing all data because it deallocates the data pages and logs only the deallocation. Truncate cannot be rolled back and does not support a where clause. Understanding the difference between union and union all is crucial for efficient query writing. Both operators combine the result sets of two or more select statements into a single result set. The key distinction lies in how they handle duplicate rows. Union automatically removes duplicate rows from the final result set, which involves an additional sorting and comparison step. Because of this duplicate checking, union tends to be slower, especially with large data sets. Union all, on the other hand, includes all rows from both select statements, including any duplicates. Since it skips the process of checking for and removing duplicates, Union all offers significantly better performance when duplicate rows are acceptable or non-existent in your combined results set. Another common point of confusion is the distinction between the where and having clauses. Both are used for filtering, but they operate at different stages of query execution. The where clause is used to filter individual rows before any grouping occurs. You can use it to filter data based on conditions applied to columns in the table. The having clause, conversely, is used to filter results after rows have been grouped by the group by clause. It specifically works with aggregate functions like count, sum, avg, max, and min to filter grouped results based on aggregate conditions. So remember, where filters rows, having filters groups. Transactions are a fundamental concept in database management, ensuring reliable and consistent operations. A transaction is a single logical unit of work comprising one or more SQL statements treated as an indivisible sequence. The integrity of transactions is governed by the ACID properties: atomicity, consistency, isolation, and durability. Atomicity ensures that a transaction is either fully completed or completely rolled back. Consistency guarantees that a transaction brings the database from one valid state to another. Isolation means concurrent transactions execute independently without interfering with each other. Durability ensures that once a transaction is committed, its changes are permanent. Commit saves the changes, while rollback cancels failed or unwanted transactions, restoring the database to its previous state. Indexes are special lookup tables that the database search engine can use to speed up data retrieval operations. Think of them like the index in a book. They allow you to quickly find specific information without reading the entire book. While they improve query performance, they also add overhead during data modification operations like inserts, updates, and deletes, as the index itself needs to be maintained. There are two main types, clustered and non clustered. A clustered index sorts and stores the physical data rows in the table or view based on their key values. There can only be one clustered index per table. A non clustered index, on the other hand, stores references to the physical data rows, meaning the data itself is not physically reordered. These are particularly useful for large data sets. The group by clause is a powerful SQL tool used to group rows that have the same values in specified columns into a summary row. It's frequently employed with aggregate functions such as count, sum, avg, max, and min to perform calculations on each group. For example, if you want to find the total sales for each department, you would group by department ID and then sum the sales. This clause is indispensable for reporting and analytics, allowing you to derive meaningful insights from large data sets by categorizing and summarizing information. Understanding group by is key to performing effective data aggregation. When defining string data types, it's important to choose between char and varchar as they have different characteristics and performance implications. Char stores fixed length strings. When you declare a char 10, it will always reserve 10 characters of space, even if the actual data is shorter. The remaining space is padded with blanks. This can be efficient for fixed size values because it offers faster access. Varchar, short for variable character, stores variable length strings. A varchar 10 will only use the storage space needed for the actual string length, plus a small overhead for length information. This saves storage space, especially when column values vary greatly in length. While char can be faster for exact length comparisons, varchar is generally preferred for its storage efficiency. Let's discuss two more practical SQL concepts: stored procedures and temporary tables. Stored procedures are precompiled collections of one or more SQL statements stored within the database. They act as reusable SQL programs, improving performance by reducing network traffic and offering enhanced security through access control. They're excellent for encapsulating complex business logic. Temporary tables, on the other hand, are special tables that store session specific data. They exist only for the duration of a user's session or a specific transaction and are automatically dropped when the session ends. They are incredibly useful for breaking down complex queries into manageable steps, storing intermediate calculation results, or manipulating data without affecting the permanent database tables. Preparing for SQL interviews requires a focused approach. My first tip is to practice, practice, practice. Regularly write SQL queries for various scenarios to build muscle memory and problem solving skills. Secondly, focus on key areas frequently tested. Master joins, understand how indexes work, grasp database normalization principles, and comprehend transactions. These topics are foundational. Thirdly, understand database design concepts. Beyond writing queries, being able to articulate why certain designs are good or bad shows a deeper understanding. Finally, use popular database systems like MySQL, PostgreSQL, SQL Server for your practice. Hands on experience with these systems will prepare you for diverse interview environments. Thank you for joining this SQL training session. We hope this guide provided valuable insights to strengthen your SQL skills and support your interview preparation. This material was prepared by Nargis Aminimokadam and MahdiAbolfathi from RAI Framework LLC to support students and data professionals in advancing their SQL knowledge. We encourage you to continue practicing these concepts and applying them in real world scenarios. Thank you, and we wish you continued success in your learning and career journey.